A compound inequality is an inequality formed by two other inequalities. There are two types of compound inequalities. There's or compound inequalities and compound inequalities. Let's look at or compound inequalities first. An or compound inequality uses the word or. We graph an or compound inequality by graphing the two separate inequalities on the same number line. So first we'll graph x is less than or equal to -1. X is less than or equal to -1 because of the equal sign. I have a closed dot at -1, and then an arrow to the left indicating that x can be anything less than -1. Then I'm going to graph x is greater than 4 on the same number line. Open dot at 4 because x can't be 4. Arrow to the right because x can be anything greater than 4. This two arrows pointing out shape is the shape of every or compound inequality. X can't both be less than or equal to -1 and greater than 4 at the same time. So the solutions are the values of x that either lie in this region or this region. Examples are -1, -1.5, -2, -17, -1 billion, any value less than or equal to -1, as well as all of the values greater than 4. So 4 is not a solution, but 4.1 is, 5 is, 73, 100. Any value greater than 4 is a possible solution. When you're given a situation, sometimes it can be described with an or compound inequality. I think I just made these situations up, so I don't think they're actually true. At airport security, travelers under the age of 3 or over the age of 65 may keep their shoes on. I don't think this is true. So we have two different inequalities to describe this. Ages under 3 or ages over 65. So this is described by an or. It has the word or in it, and it gives two separate inequalities, less than 3 or over 65. Now this would be extremely unpleasant to graph if I wanted you to include the numbers in between, even with some sort of scale. So I'm just going to have you put the 3 and the 65, and then have an open dot at 3, arrow to the left, open dot at 65, arrow to the right. So it says under 3, so it can't include 3, open dot, over 65, can't include 65, open dot. Possible solutions are it's okay to be 1 or 2 or 66 or 103 or 110. I guess it's okay to be 3,000 years old. I guess it's okay to be -10, technically. Okay, second example. You should stay inside if it is colder than 15 degrees or if it is at least 100 degrees. This is kind of a tricky one. Colder than 15 means a temperature less than 15. So x less than 15. 14 degrees, 13 degrees, 12 degrees, 11 degrees. Those are all temperatures colder than 15. Or if it is at least 100 degrees. At least means it can be 100. It can also be 101, 102, 103, 104. Again, I'm going to let you just put two values on this number line to graph. So x is less than 15 or greater than or equal to 100. Possible solutions are 14, 13, -2, or values greater than or equal to 100. So it's okay if it's 100, 110. You should definitely stay inside if it's 130 degrees.